so this brings us at last to the end of the first section. So now we go on to the second section. This is called the Cartesian product. How many people have seen Cartesian products before? Just a couple of you. Yeah? Okay, so the Cartesian product is an important thing which pops up in lots of different areas of mathematics. It's a fundamental way that you can take two sets and make a new set out of them. And here's how it works. So if A and B are sets, then the Cartesian product of A and B is the set. So it's written like this: A times B, and it's a set of all ordered pairs A comma B such that A is in A and B is in B. Yeah.
These are finite sets.
Not necessarily.
It also applies to.
It also applies to all sorts of sets. Yeah. Yeah.
Without making any special distinction, can you say, for example, that if you want to find all points on a certain plane, you could say it's an element A cross B without any making the special distinction that the elements A cross B are specific points, both in pairs and numbers? Can you want to say that?
Yeah, you could do that. I mean, the sets can be anything.
Yeah.
So the sets.
Without making any special distinction. So do we distinguish between pairs and numbers and points? No.
I mean, so the Cartesian product is sort of neutral on that particular topic. You know, you can do the Cartesian product of any two sets, whether you think of them as points or numbers or other sets or whatever. Yeah, but this is actually one of the ways that the fundamental device that we use to write down a plane. So as we'll see just now, R2, the xy plane, is R times R. It's a Cartesian product of R with itself. So here are some examples. So for example, if A is equal to 1, 2, and B is equal to A, B, C, then A times B is equal to, okay, so first of all, A times B, the Cartesian product, is a set. So if I'm going to write down A times B, all the elements in that, I need to put set brackets around whatever I'm going to write down. Yeah? And then everything in A times B is an ordered pair. So that means I'm going to use round brackets for the ordered pairs with commas, not semicolons. And what I'm going to do is I'm going to list all the possible ordered pairs I can get by taking the first thing from A and the second thing from B. Okay. So what are the possibilities? Well, A has 1 and 2 in, so you can have 1 and then small a, or you can have 1 and small b, or you can have 1 and small c, or you can have 2 and small a and 2 and small b. And 2 and c. Yeah, that's. Yeah.
Are these like similar to matrices in that aspect?
Matrices. You can think of them as, in fact, the very next thing I'm going to write down is you can sort of think of them, a Cartesian product is sort of like a matrix.
B cross A is not the same.
Yes, that's an important point. So actually, I've got two different points I want to talk about now. So B cross A in general is not the same as A cross B. So I'll come back to your point in just a second. Let me deal with her point first. If you work out B cross A, so now you take the first thing from B and the second thing from A. Yeah? So now this is right, so A comma 1, and then A comma 2, and then B comma 1, and then B comma 2, and then C comma 1, and C comma 2. Is this set equal to this set? Remember, one of the first definitions we gave in the first lecture 2 days ago was how do you know when two sets are equal? Two sets are equal if all the elements are the same. Okay, so every element of A is an element of B and vice versa. Okay, so here's 1A. That's an ordered pair. So 1A is not the same as A1. Yeah? Okay, so is 1A anywhere in here? No. Okay, so that's the end of the discussion. These sets are not equal. You don't need to look at the rest of the elements. Okay, so A cross B that here A cross B is not equal to B cross A. What would be the technical term that we use if A times B is not B times A? We say that the Cartesian product is not what? Commutative, yeah? So the Cartesian product is not commutative. That's what that means. Normal multiplication of numbers is commutative, yeah? 3 times 2 is 6, which is the same as 2 times 3. And normal addition of things is commutative, right? I mean, 5 plus 107 is the same as 107 plus 5. Yeah? But multiplication of sets using the Cartesian product is not commutative.